Okay, good morning everyone. Assalamu alaikum. At first, I would like to thank the organizer of this conference, IEEE Control System Society Malaysian chapter. Uh, I am Dr. Towfiqur Rahman, Department of Computer Science and Engineering, University of Asia Pacific, Bangladesh. So today I'm gonna present my paper, Designing OWC system with millimeter wave and optical modulations for different optical band. So these are the outlines like introduction, motivation and objectives, main idea, literature review, methodology, results and discussion, conclusion and key references. So at first we need to know what is optical wireless communication. Like optical wireless communication is a high speed communication system that uses light signal or light waves. This light signal can be the visible light or infrared light or ultraviolet. So we use this light signal to transmit high bandwidth, and we want to transmit a lot of data within free space optics or optical fiber. So we are using light signal because of high bandwidth, low latency, and uh, definitely the security, because out of the light spectrum or light hotspot, no one can access this internet or this system. So another uh, contribution is we introduce here the millimeter wave. Like millimeter wave frequency range is 30 gigahertz up to 300 gigahertz, which provides high bandwidth and is suitable for 5G and 6G communication. So we use here 60 gigahertz band, especially because of unlicensed, and it offers the atmospheric absorption within a certain range. So traditional RF signal, which has some bandwidth limitations and signal congestion. So due to high bandwidth and to avoid this kind of bandwidth limitations, we propose here integrating millimeter wave with advanced optical communication technique and optical modulator like magenta modulator, phase modulator, amplitude modulator, and frequency modulator, enabling high speed interference avoidance and to secure long range communication. So the main idea of this paper to design and evaluate the performance of an optical wireless communication system integrating multiple optical modulation approach and 60 gigahertz millimeter wave with different optical band. So you can see here the optical band from O band up to U band. Okay, so the goal of our paper is to create the scalable and high-speed OWC system that performs reliable over short range and the long range also. So and also we're trying to look at the adaptive modulation techniques and band selection for which band, like which optical band is suitable for this kind of communication system. So and in that case we used magenta modulator, phase modulator, amplitude modulator, and frequency modulator. So in the literature part, if we look at this table, reference number one, Kadir and Anwar in 2014, they focused on urban optical wireless challenges. Basically, it was a theoretical analysis, and they they found the limitations for FSO model. And reference two, they focused on OWC system for IoT applications, and this one also kind of survey paper. So they try to find out the gap, research gap or limitations of this kind of OWC system. Reference 4, they actually introduced the 5G millimeter wave system, but in case of radio over fiber, they use WDM system. So they enhance their system performance, but they need more optical amplifier to boost up the signal. So difference 15, they use millimeter wave and phase modulator. It's a phase modulation technique. So the 60 gigahertz, they also use 60 gigahertz OWC channel. They achieve high data rate. Uh, and reference number 16, they focused on DML based millimeter wave WDM system, and it was totally experimental work. And in experiment, actually they found problems for ambient light. So that means daylight or sunlight, whatever. So reference 19, they checked in their model the multi-band optical, different types of optical band system, but it was over the optical fiber. Okay. So the main methodology of our model is actually it was the simulation based work. So in our simulation model, we design and evaluate the performance of an optical wireless communication system that integrates multiple modulation techniques over the different optical bands. The methodology consists of few things like we used pseudo random bit sequence generator. Using this generator, we generate the data band like binary data 1010, and after that, using NRZ pulse generator, we convert this binary data to the optical pulse or optical signal. Then this electric signal, sorry, this electric signal and electric pulse, we need to put into the our optical channel. That's why we have to use the more laser, optical laser, and definitely the frequency that we have used, the 60 gigahertz. So these are the model of our system. Like at first we use the binary data, then we convert it into the electric pulse using energy pulse generator. Then we use optical modulator. Then this electric signal with optical signal we put into the modulator. Then modulator output was the optical signal, and then we put into the free space optics. And the receiver part, we used photodiode. This photodiode actually received the optical signal and it convert into the electric signal. After that, we use low pass filter to filter out the optical noise or unwanted signal actually. Then we use 3R regenerator to regenerate or reshape the optical signal. And finally, we measure the signal quality using PER analyzer. So these are the parameter of our simulation model, and we basically we used BER, bit error rate, and Q factor and I diagram, these three things to measure the signal quality, and also to check the optical spectrum. We used optical spectrum analyzer OSA. So in the results and discussion, we can see with the increasing of the distance, our Q factor and BE are also decreasing. So in that case, we have 4 modulator and we check the performance. So in this table, we can see a complete result first of all we use phase modulator, then amplitude modulator and frequency modulator and Mach Zehnder modulator. In the both cases we found the Q factor and BER value, and in the left side you can see we use different optical band like O band, E band, S band, C band and L band. So that means using 5 different optical band. Also, we use 4 different optical modulator. Then we found the results. So in the result section, we are also using the eye diagram. If we can see from the figure 3, 4, 5, and 6. Like figure 3, this eye diagram for phase modulator. From the figure 4, the eye diagram from amplitude modulator. So this figure actually you can show the signal quality degrades with the increase of the distance. Like initially we used 10 kilometer. In that case, the signal was very good. The eye diagram of the eye diagram is quite impressive without noise. So when we increase the distance like 50, 70, 90, around 100 kilometers, so you can see the eye diagram is quite messy, and uh, with the increase of the distance, the eye diagram also degrades its quality. So in conclusion, we can see we actually we conclude some few things like Mach Zehnder modulator. It emerged a most reliable and consists of the modulator maintaining low BER and stable Q factor. But amplitude modulator shows the superior performance in short range transmission, delivering the high quality signal. But frequency modulator demonstrated competitive performance, especially in O band and E band signal. So we can say our proposed model actually we successfully we implemented our model, which combined with millimeter wave and the different types of optical modulator and also different types of optical band, and we successfully analyze the system performance with this model. So these are the key references that we used in our model or in our paper. So thank you everyone for listening my presentation, and also again I am to give thanks to give me the opportunity to present by online. So I want to give thanks UITM and IEEE Control System Society Malaysia. Thank you everyone, and if you have any question you can ask.